All right, folks, for the last couple of days, we have been working on using long division to divide polynomials. Today, we are going to learn a second method for doing polynomial division problems, and that method is called synthetic division. Now, what I want to do here is start out by doing a problem with long division, and then I want to show you the same problem using synthetic division, because I want you to see that it will truly give you the same answer. So we're going to start out with this problem. X squared plus 3x minus 43. And we're going to divide that by x plus 8. Now, what I'm going to do is draw my line here, and over here on this left side, I'm going to do long division, and then I'm going to come over here on the right and do this same problem using synthetic division. Now, based on our lesson yesterday, you know that one of the things I need to check is I need to check to see if I'm missing any terms. So this thing starts out with x squared. And then I have x to the first, and then this doesn't have an x, so that would be like x to the 0, so it goes 2, 1, 0. Didn't skip any powers, so this problem is good to go the way that it is. So let's start by writing it as a long division. So we've got x to the second plus 3x minus 43. And then we're dividing that by x plus 8. Now, recall how this goes. When we use long division, the first question we ask is how many times will x go into x squared? How many times will x go into x squared? And remember what that amounts to. You're asking what would you have to multiply times this x to get him to become an x squared. Well, you know it would take x times x to get you an x squared. So how many times will x go into x squared? The answer is x times. And we put that up above the 3x. All right, now we're going to multiply what we put on top by this divisor. So we're going to do x times x. That's x squared, and it goes underneath. And then we're going to do x times 8. That's 8x, and that goes underneath. Now, here's that step that I warned you was kind of dangerous, the subtraction step, because you got to remember you're subtracting both of these terms. So you're subtracting x squared and you're subtracting 8x. So x squared minus x squared cancels both of those out. And then 3x minus 8x. 3 minus 8 is a negative 5. So I get a negative 5x from my subtraction. Now, we're going to bring down our very next term of negative 43, and then we're going to go through our dividing process one more time. So now we're asking how many times will this x go into this negative 5x? So, in other words, what would you have to multiply times this x in order to get negative 5x as the result? And the answer is negative 5, which we put up on the top. We multiply negative 5 times x and get negative 5x. And then negative 5 times 8 and get negative 40. And we subtract. So negative 5 minus negative 5 cancels these two out. And then negative 43 minus negative 40 minus negative 40 is going to change to plus 40. So we're doing negative 43 plus 40, which is a negative 3. So I have x minus 5, remainder negative 3. And remember, I asked you to write that as x minus 5 minus 3 over your divisor of x plus 8. So we got x minus 5, and we got a remainder of negative 3. All right, now, I'm going to come over here now, and I'm going to show you this same problem using synthetic division. Now, the first change you're going to notice is we are not going to use the long division symbol anymore. So the symbol that you use when you want to do synthetic division is kind of this little backwards L. So that symbol that I just drew in blue is the symbol that shows that you're going to use synthetic division. And what you're going to do is you're going to put a number right here in this little space, in the crook of that L. Now, here's where you get the number that you're going to put there. You're going to get that number by looking at what you're dividing by. And what you want to do is take that last number, so that positive 8. Now, what I'm going to do is I'm not going to keep that as a positive 8. I'm actually going to change his sign. So I'm going to change that from a positive 8 to a negative 8. So I'm going to put negative 8 right here. So that little backwards L that I've written in blue is the symbol for synthetic division. And in the crook of that L, we're going to go to what we're dividing by, and we're going to take that second number, and we're going to use the opposite of that number in that spot. Now, I know you're probably wondering, why do I do the opposite of that number? Well, you're doing the opposite of that number because of these subtractions. You're doing the opposite of that number because of those subtractions that we use when we do long division. Now, over here beside of that backwards L, we are going to put the thing that we're dividing. The x squared plus 3x minus 43. Only we're not going to write the variable part of this. We're not going to write the variables in that. What you're going to do over here is you are going to write coefficients only. So when I look at x squared, I know my coefficient is a positive 1. For 3x to the first, my coefficient is a positive 3. And for minus 43, my coefficient is a negative 43. So I'm going to come over here and I'm going to write 1, 3, and negative 43. So what I do is for the part that I'm dividing, I take the 3 coefficients, one from each term, and I write those beside of that backwards L. So let's kind of recap what's going on here. The backwards L is the symbol for synthetic division. You put a number right there in the crook, and you get that from what you're dividing by. You take this number at the end, and you take the opposite. So we're putting a negative 8 right there. And then beside that backwards L, we're going to take what we're dividing and put just the coefficients. So one coefficient for each term. So 1, positive 3, negative 43. So that's how we get this thing set up. Okay, so time to do the synthetic division. I'm going to draw a line, and I want you to notice that I've left some space between my numbers and my line because you're going to be putting some more numbers in there. Now, here's what you need to know. This very first number of 1, you are just going to bring straight down and put it below that line. So that's how synthetic division always starts, is we take the first coefficient and we bring it straight down and put it beneath the line. Now, from that point on, you are going to multiply and add over and over and over again until you reach the end of the line. So it's going to be multiply, then add. Multiply, then add. So that's the pattern to this. So here's what I mean. Okay? First thing we're going to do is we're going to multiply our negative 8 times that 1. Our negative 8 times that 1 that we put below the line. Negative 8 times 1 is negative 8. I'm going to put that answer right here below my 3. So I did negative 8 times 1, which is negative 8, and I bring that up here and put it underneath the next number, which is that 3. Now I'm going to add. So I'm going to add 3 plus negative 8. 3 plus negative 8 is negative 5, so I put that number below the line. All right, now time to multiply again. So I'm going to do negative 8 times negative 5. Negative 8 times negative 5 is 40. And I'm going to bring that right here and put that below my negative 43. And then I'm going to add. Negative 43 plus 40 is negative 3. So let me kind of clean this up a little. all my little lines I drew here and make sure you see what we just did there. Okay, we started out the process by bringing this 1 straight down below the line. And what happens is your negative 8 multiplies by that number that's below the line. So negative 8 times 1 is negative 8. You put that underneath your next number, and then you add. 3 plus negative 8 is negative 5. All right, now that negative 5 that's below the line gets multiplied by the negative 8. So negative 8 times negative 5 is a positive 40. You put that underneath the next number, and then add. Negative 43 plus 40 is negative 3. And then I don't need to multiply anymore because there's no more numbers out here on the end. Now, I want you to look at the 3 numbers you have. You have a 1, you have a negative 5, and you have a negative 3. You have a 1, a negative 5, and a negative 3. And I want you to look over there at that answer and see if you see those numbers in that answer. So let me talk about this. First of all, where can you see the negative 3 in the answer that we got over here when we did long division? Well, you see the negative 3 in the remainder. So this number out here on the end is your remainder. Always. That's how it will be, is that number on the end will be your remainder. Now let's talk about these other 2 numbers. We got a 1. Where in this answer do you see a 1? Well, there is a 1 in front of that x. So it's 1x. And then negative 5. Where do I see negative 5 in my answer? Well, that's this other term. That's this other term. So when I see 1, negative 5, and negative 3, I know that's the remainder. The last one is the remainder. So this is 1x minus 5 with a remainder of 3. So that would be minus 3 over x plus 8. So I want you to notice that that produces the same result. And I want to point out one more thing. These 2, and I guess I should mark this right here. These 2 are the coefficients of the answer. And what I want you to notice is our original problem had x squared as its first power. I want you to notice that your answer has x to the first. And that's the way it will always be. So since this started out with x squared, the exponent in your answer should be 1 less than that. It should begin with an exponent that is 1 less than that. So it's 1x to the first minus 5 with a remainder of negative 3. Now I know that may be a little confusing at first, but hang in there with me. Let's try another one. All right, let's do this time 2n squared minus 16n plus 19. And we're going to divide that by n minus 7. Now, let's do this one this time with only synthetic division. So first, let's check and see if we've skipped any powers. We had n to the second, n to the first, and then n to the 0. So we're good there. We didn't skip any powers. All right. Draw your synthetic division symbol, backwards L. To figure out what to put in the crook of that L, look at your binomial that you're dividing by. Its last number is a negative 7, so remember we're going to do the opposite of that and put a positive 7 right there. Now, beside that backwards L, we're going to put our coefficients. We have 3 terms, so we're going to need 3 coefficients. So it's going to be 2, negative 16, and 19. So we take the coefficients straight out of that trinomial and just write them down. All right, the synthetic division process always begins by bringing down that first coefficient and putting it below the line. Now we're going to multiply. So it's multiply then add, multiply then add. Okay? So this 2 that I've placed below the line is going to get multiplied by this 7. So 7 times 2 is 14. I place that 14 below that very next coefficient. And then I add. Always add. Negative 16 plus 14 puts negative 2 below the line now. Now that negative 2 that I just put below the line gets multiplied by 7. So I do 7 times negative 2. That gives me negative 14, which I put underneath the next coefficient of 19. And we add. So 19 plus negative 14 is 5. Now, how do I get my answer out of this? Well, I know this is my remainder. And I know that 2 and negative 2 are the coefficients for my answer. So 2 what? Well, this thing started out with 2n to the second. I'm going to reduce that exponent by 1. So this is going to be 2n to the first. And then minus 2. And my remainder of 5 means that I'll put plus 5 over my divisor, which is n minus 7. Now, I don't know if you recognize these examples or not, but these are the same examples that I did with you in yesterday's video, just recycled. So if you copied any of those down, you can kind of look back and confirm that these answers are coming out the same. All right. Let's do k to the third minus 17k plus 32, and we're going to divide that by k plus 5. Now, let's first of all see if we skipped any powers. We have k to the third, then k to the first. So yes, we did. We skipped k to the second power. So remember that we're going to need a 0 in there as a placeholder for him. All right, so let's get ourselves set up for synthetic division. Backwards L. We go to our binomial, k plus 5. He ends with positive 5. We change that to its opposite, so you're going to put a negative 5 in your synthetic division box. Now, coefficients are going to come over here to the side. So I have a 1, a 0, a negative 17, and a 32. So 1k to the third plus 0k squared minus 17k plus 32. So notice how I've got to insert that placeholder this time. All right, we begin by bringing down the first coefficient and placing it below the line. So this is going to start off with a 1. Now, we're going to multiply. Our numbers underneath the line get multiplied by this negative 5. So negative 5 times positive 1 is a negative 5. I put that underneath the next coefficient, and I add. 0 plus negative 5 is negative 5. I multiply negative 5 times negative 5. That's positive 25. I put that under the next coefficient, and I add. Negative 17 plus 25 is 8. I multiply negative 5 times 8. I get negative 40. And I add. 32 plus negative 40 is a negative 8. So I know these three are my coefficients, 1, negative 5, and 8, and my remainder is that negative 8 out on the end. Now, what are these the coefficients for? Well, this thing started off with k to the third power. So this is going to reduce by 1. So instead of 1k to the third, I'm going to start off with 1k squared. That first exponent in your answer should always be 1 less than it was in the problem. Then it's going to be minus 5k plus 8. And then with my remainder of negative 8, I do minus 8 over k plus 5. So notice in this synthetic division process, we drop that first coefficient down, and then we alternate. We go above the line, then below, above, then below, above, then below, until that whole thing. All right, let's look at one last example. All right, let's check for missing terms. We have x to the fourth, x to the third, x to the first. So that means right in here we need a 0x squared as a placeholder because they have skipped here. All right, synthetic division symbol. The number that we will put there is going to be the opposite of that number. Opposite of positive 2. So we're going to put negative 2 right there. Now, coefficients. We have 1, 2, 3, 4, 5 terms counting that placeholder. So we're going to put those coefficients here. So 2, negative 4, 0, 3, and negative 28. All right. Start your synthetic division here by bringing down the first coefficient and placing him below the line. We're going to multiply negative 2 times 2. That is negative 4. And then we add. Negative 4 plus negative 4 is negative 8. We do negative 2 times negative 8. That's 16. And we add. 0 plus 16 is 16. We multiply negative 2 times 16. We get negative 32. And we add. 3 plus negative 32 is a negative 29. And then we finish this off by doing negative 2 times negative 29, which is 58. And we add. Negative 28 plus 58 is 30. Now here's what we know. That number is the remainder. These other 4 are the coefficients for our answer. Now, this 2, what is he going to sit in front of? Well, if we look up here, we see we had 2x to the fourth. We're going to reduce that exponent by 1, so this is going to be 2x to the third. And then it'll go down from there. So we'll have minus 8x squared plus 16x to the first minus 29. So the exponent on this first term will always be 1 less than the problem. And then our remainder is 30, so we'll have plus 30 over x plus 2. Now hopefully those 4 examples will be enough to kind of get you going on synthetic division. If you do have questions, if there's anything about that that you don't quite get, then please be sure and let me know.